I've been following along with Paul McCorders Raspberry Pi Pico lessons, and I made a video a couple days ago following along with doing NeoPixels using the PIO state machines on the Pico, and everything was working fine, and uh, got finished with my homework and posted a video. And yesterday, I decided, well, let's put it into I decided to make it into a um, module, or put it in classes and put it in a module so that you didn't have to interact with all the code when you wanted to do some animations with your NeoPixels. And got that done, and everything was working fine. And then I said, well, let me try out. I've been using a little 12 pixel ring that they're fun for using, and everything, and it worked fine. But I also have a 60 pixel strip that's a flexible strip that I use, and uh, I like doing things with that too. So I tried using the code on that, and all I got was glitches. I said, "Oh my goodness." So anyhow, I had done things my way a little bit different than Paul did on his, and but I decided went to trouble copying all Paul's code the way he had it in there, and tried that, and it still glitched on the 60 pixel thing. So was scratching my head for a little while, and this is where I think I've come to see where the problem is and how I had to fix it. Let's see. Let's go to my code first. So this is the original code, and this is where we were using the state machine put to put each uh, pixel color into the 24-bit pixel color onto the state machine. And like I said, every pixel you had to loop through it and everything. So you were using MicroPython to loop through it. And you would think they'd be pretty fast, but evidently it wasn't fast enough or whatever, because I decided that what happened is that it was doing this calculations and separating RGB out and everything, and then putting it back into a 24-bit thing for each pixel. And for the 12 pixel string, I think it had enough time to uh, keep up with the MicroPython kept up with PIOs. But on the 60 pixel string, I think that PIO run out of data and just pause, because that's what it does when it can't doesn't have any data. It just stops, and that way the NeoPixel just figure, well, that was all they had, the data they had, and after a pause, it would catch up and start over, and it would think, oh, it's starting over again, because that's what it would show up on my 60 pixel string, is it would start doing something, and then would go back to the beginning and start over, and kept doing that, and I just I said, wow, that's kind of crazy. And I thought, well, maybe I'm doing all this multiplication to get the brightness. And I thought, well, maybe I need to switch up the way I did that. And I, that was part of the issue, I'm sure. But even using full brightness, I took commented this out and just used the RG and B out of the pixels on there. Still glitched on the 60 one. So um, must be, I assume that it's still just MicroPython just too slow for keeping up with it on the longer strings. Uh, went back to the original code that I had borrowed, and plus the one that's the example on the uh, PIO documentation has this also, and they were using the array module, which is a imports a different type of data structure, and it's like a it's just a array of like variables. So they're all either integers or they're all um, signed integers or they're all this, but they all have to be the same. So that's what they were using was using just a 32-bit integer and making an array out of them. And you can see here, this is the code on the code that I had found. And I think it's exactly the same code that's on the example code. And they import this array module and then they create an array.array. The I tells it that they're all going to be unsigned 32-bit numbers. And then it just creates array for um, of the number of pixels that you have, and then the difference is between having to iterate over each of the pixels in like we do with list is that it you go in here and they use where is it this SM put and you put the whole array in, it iterates over the whole array. So that's the difference. You don't have to loop through anything or anything. You just put that whole array that you created with all the pixels in it, and it just takes them as it just has them available to the state machine, so there's no breaks in it. And that was the big difference. So I thought, well, I guess I'm going to have to redo all my code to fix that. So anyhow, so with my other one, I was updating the pixels or sending the pixel data to the string or the pixels with this show thing here. And it was doing two jobs. It was taking care of the brightness, adjusting the brightness, plus it was putting this together and sending it to and then using sm.put to send the data to it. So on my new code, I have separated that out into two different things. So the show now only has the self put, and we're because it's a self dot because it's in the um, class module now, so it has to be self dot. And I'm just calling it AR. And that's the only thing this show does. It just puts out that to the thing. Now, this put is actually a blocking thing, so you can't do, I mean, it happens really, really fast, but with 60 pixels, it's still going to take a little bit of time. But um, it's going to block while you're doing that. And anyhow, but to do the colors, I decided that instead of doing the colors, storing the colors in, the RG and B, that each time I stored a color into the array, and I think this was pretty much, they didn't really go into this on either one of the examples that I looked at, but that each time you uh, find that you set a pixel, I just set it at the time it's the color set and set the brightness. I do the multiplication for the brightness to get that. And then at the same time, I turn it into that 24-bit number that we need to be that. And I just return that. So that's when I return this, it's going to go into the pixel that we have. So like this isn't really a good example here. Let's see where to have a good example. Okay. So here's one here. That's not a great example either. Okay. All these are doing the modulo, but you're actually your AR, and this is just your pixel number, and I'm just working on my pixel numbers here. I'm going looping through it, but you're doing this SB, you're sending it a RGB value, and what's going to be returned and put into the thing is the 24-bit value. So anytime that you have to put a number, you put a color into this, that you are um, going up there and changing you're doing the math and adding in the brightness and everything like that. So it's going in that way. And I had to change not the complete code, but I had to change quite a few things. And and when you're changing them all, I missed a few, and you get errors when I work my way through all the examples that I have at the bottom down here. And um, they are all working now, and I'll probably post this on my GitHub now that it's a working one. And it works really well with the other with uh, the 60 pixel LED, and I would assume it's going to work with whatever size that you have now. So anyhow, we got that, and just that's basically what we're doing. And the big deal is that instead of looping through each pixel color, this is doing the whole pixel array that they have and putting it making it available to the state machine as fast as it can go. So that's the difference. Um, I added a couple when I created that's probably all I got to say about fixing it, but I added a couple different things that I might show here. Um, all these I did it. This random pixel is one of them. So let's go down the bottom. I think I might have that one already done. So I got random pixel. And basically all you're doing with that is it's just turning a pixel on and then uh, clearing it and turning another pixel on. Random pixel and random color. So let's see if this runs. I don't know. There you go. So it's kind of just blinking. So I'll go ahead. It only does so many and then stops. There we go. So I decided when I did created the random is I would give it some arguments that you could change. So uh, I got them all so that they have default. So it's 100 and a certain dwell time in between pixels. And this clear pixel equals true is tells it down here that you're going to clear the screen again in between. So uh, that clear that pixel. And if you don't clear that pixel, it just means that that color is going to be there, and it's either going to stay or it's going to get overwritten by if it happens to pick that color, that pixel again, and it'll change the color possibly or something like that. So if we set this to false, so let's go down here and put CLRPIX equals false. And now we'll run it. And this time it should just start filling it and then it'll start copying over them. So yeah, it's pretty washed out. But you can see it's just changing the colors as you go. So that was one that I did. And another one that I have is this bounce one here. And basically, you just give it a color, and the pixels are going to just go in opposite directions around it. So let's run this one. This is actually mainly just for the rings or whatever. And you can, again, you can add uh, things. You can add a dwell to it. What was my dwell up there on that? I had 0.2. So if we go 0.05, let's see. DWELL equals 0.05. And I think I had loops as well. Yeah, loops. We'll do 10 loops since we're going so fast. Yeah, we'll try running again, see how that does. Yeah, you see it's much faster. So anyhow, that's probably all I got for today. Um, I think I finally have a working library module that I can use for PIO. And I did also, I don't know whether I mentioned it or not, but I added Paul's. So we have state machine zero. So then we add one when we initialize the first one, we'll add another to it. So you can do a second set of neopixels. Um, that works fine, but for like animations and stuff like that, um, the you're if you have an animation like that sparkle or whatever you call it, the random picks thing, it's going to do the random picks on the one string, and then it'll do the random picks on the other string, so they won't be blinking at the same time. Um, I don't know what you would do about fixing that. Um, but anyhow, that's what I got for today. Thanks for watching. Have a great day. Thanks, Paul, for all you do.